we're talking with LeafLabs, and you make an Arduino-shaped board with a 32-bit ARM processor. Is that
That's right.
about right?
Well, so one of the boards that we make happens to be Arduino shaped with an ARM processor, yes. And it's called the Maple. And let's see, it's been around. Betas were out in 2009, late 2009, and the real deal came out in May 2010. We're now on Rev 5 with probably a whole new version coming out late this summer.
And that's really interesting because the way we got in touch is Jessica from LeafLabs shot us an email about your new Maple mini board. And at the end of the email, she said, hey, Microchip's chip kit isn't the first 32-bit Arduino compatible platform. The Maple is, and we've been at it for years.
Well, we're trying hard not to dwell so much on these sorts of things. But yes, they did spend a lot of time on the internet, and they're backed by Microchip, so they have lots of marketing behind them uh, to try and get a lot of momentum out of their launch. And I think it was very successful. And to be fair, they use a lot in their materials, fully Arduino compatible, or maybe they accuse us of not being the first because we're not fully Arduino compatible. But honestly, to call a 32-bit platform, any 32-bit platform, fully Arduino compatible is ridiculous. I mean, that'll never be the case. Starting with the fact that an int is not an int on a 32-bit platform and a 16-bit platform, right? So, so I'm not sure that you can escape. It's a where do you draw the line? What's sufficiently Arduino compatible to be the first Arduino compatible board? And we'd rather not be nitpicky there. So, we're
That's fine. Well, I just thought it was interesting, and I thought it was worth calling you guys and hearing a little bit more about what you've been doing.
yeah, absolutely. And to be fair, I'm really glad about the chips kit stuff, only in the sense that we can see the community moving towards 32-bit, which we thought was going to happen a long time ago, and we're really pleased to see starting to happen now, and we're glad to have been a part of it. I mean, people turn to 8 and 16-bit devices these days for momentum reasons as much as anything else. And while sure, sometimes you do need 25-cent dip packages for some big project, for the most part, there's no reason not to start upgrading to real processors. And I'm really glad to start seeing it happen in lots of places.
Okay, you already said a little bit about your platform. Do you want to give a general overview for people who might not be familiar with it?
Yeah, sure, Marty, you're more careful with the specs than I am. Why don't
Well, okay, so Maple is actually a series of microcontrollers, microcontroller development boards. We started with the base one that has the Arduino form factor, and we've moved on to the Mini, which is a breadboard, fits in a breadboard. Later on this summer, we're going to have the Maple Native, which is it's great. It's got a meg of RAM, way more GPIOs, faster. Bigger processor. Um, yeah, so in general, we try to be inspired by the ease of use of Arduino and the great documentation that Arduino has, while really making transitions and breaking compatibility in places where it really makes sense for the betterment of the platform.
Yeah, the canonical example of Arduino compatibility versus non-Arduino compatibility comes up in the analog read function. If you want to be fully Arduino compatible, you would have to make this a 10-bit number. So when you call analog read, Arduino on the AVRs only has 10-bit ADCs. So on these little STM32 chips that we use, they're 12-bit ADCs. So why wouldn't we return to you a 12-bit number when you call analog read? And we do, but that's breaking compatibility. And that's one just really trivial example, but that sort of thing kind of permeates the entire platform where these 32-bit procs have just an awful lot more juice behind them and are beefier in almost every way.
Sure.
And we try not to hide that from the user.
Yeah, I mean, the PWM, if we wanted the PWM to be fully Arduino compatible, we would have to sacrifice 8 bits of resolution. And that seems crazy to me. It seems like it would be doing our users a disservice to take that away from them.
Sure, and of course your 12 bits of ADC measurement are also based on 3.3 volts or whatever your reference is instead of the Arduino's 5.
That's right. And it was not really easy to get those 12 bits. As far as we know, we're the only STM32 board out there that actually comes close to all 12 bits because we're a 4-layer board and we engineered it a couple of times to try and get the noise down. I'm not sure we get all 12, probably about 11 and change. So if you average over a couple of samples, you'll happily get your 12 bits. But that's pretty good. I think some of the other boards that we've been playing with before Maple were something like 30 and 40 millivolts of noise. And so you're talking about getting 7 bits out of the ADCs, which is a little useless.
With all these caveats, why did you choose to do up your board like an Arduino?
Well, so that's historical as much as anything. So the original concept we were chasing way back in 2009 was FPGA hardware. And the prototype board we had, which was called Maryland, was an STM32, a little ARM board, the same chips we use now, and a Spartan 3. And it was on the same board, and we were really excited about how we were going to make these two procs talk to each other and what we could do with them. And at some point, one of the engineers working on the project, iPerry on the forums, said, you know, this is quite hard. I bet if we just cut the FPGA off, we could make an ARM Arduino. We could do it in fairly short order, and I bet it would be really popular. I've wanted this for a long time. And so we started down that path, thinking of it something of a side project, and it turned out to be enormously popular, and people started writing in from all over the world saying, yes, they're so happy to see ARM Arduino finally happening. And 2 years later, we're still kind of heading down that direction. So I'm not sure that we ever sat down and said, really, let's focus on the Arduino compatibility, let's do the Arduino form factor. It was really a side project that was driven by the response that we got from the community when we actually put out the original designs.
Oh, that's really cool. Your tool chain is 100% open source. Can you tell us a little bit about that?
Marty, you want to take this one?
Sure. Well, unlike Arduino, we developed the library that goes on our boards separately from the IDE. The IDE is a fork of the Arduino IDE, so it's based on their code, which, as everybody knows, is totally open source. And instead of using ST's firmware library for the STM32s, which we find is a bit of a bear to work with, we started over from scratch and are writing a library called the Maple, which the core library is pure C and is MIT licensed. And the Arduino compatible layer, which kind of sits on top of it, is a mix of MIT license when we write it and lesser GPL when we were able to borrow code from Arduino.
We do put a certain amount of thought and arguing into the licensing. I think we're all very happy using MIT licensing for LibMaple. And one of the reasons is, and this has turned out to be the case looking at the past couple of years of sales, was that one of the things we really wanted to get out of open sourcing everything, I mean, we use Creative Commons for the layouts and MIT license for LibMaple, is that even if you are making a product, you know, be it as part of a consulting gig or you're a big company or whatever, if you're using STM32, there's really nothing preventing you from building around Maple, and then when you're ready to go to volume, just drag and dropping the whole thing into your project, reusing the libraries, modifying them to your needs, and really kind of adopting the foundation that we built and not having to worry about getting mired in some sort of licensing mess. You know, all of us here have been writing open source software for a long time, and we all know what a minefield it's like when you want to try and build off something that already exists about whose licensing toes you're stepping on and that sort of thing. And we thought Maple would be way more valuable to people if they could, with confidence, know they could build on top of it and not end up getting sued one day. And so that's why we went with MIT license and not with, say, a more strict copyleft GPL or something like that.
What extra rights does the MIT license give you that the GPL doesn't?
The GPL forces you to copy left, which means that any derivative works are also going to be GPL. Whereas the MIT license is a little bit more liberal, and that's not the case. There's no riders attached. It's pretty much use however you want. We retain the copyright, incidentally, but not that's not really valuable unless you're going to do a dual licensing scenario or something like that. Which, I don't know. We can talk. That's another conversation if you want to get into it. But where do you want to expand on?
No, I think you pretty much said it well. The MIT license allows you to take it and, you know, just do whatever you want with it. You don't have to. You're not forced to redistribute the source code in case, like, it's your secret sauce in whatever killer app you're developing.
To reiterate, the software license then for the tool chain is generally GPL. The Arduino IDE is GPL. Your compiler is GPL. These things are all GPL.
Yeah, the compiler is GCC, incidentally.
Your hardware license is Creative Commons what?
So it has been share-alike, and I think perhaps that was an oversight, just because different people were working on the hardware and the software, and we didn't catch it. But in the future, we're just gonna do the most liberal Creative Commons.
Probably attribution.
Yeah, attribution.
Everything you do is in a GitHub repository.
That's right.
That's right.
We are big proponents of GitHub. We've really enjoyed switching over from Subversion. And we've even got the hardware people using it now, which is a big accomplishment for anyone who's worked with hardware people before and had trouble getting people to use versioning. one really nice thing about the hardware tool that we use, we switched over from Eagle, which many people think is open source, but is not. It's just simply free, free as in beer. We use KiCad instead, which is an open source project, and we did that partially so that we didn't have to force any of our users who wanted to look at our designs to use non-free software if they didn't want to, and we wanted to support the KiCad project. But one of the fringe benefits that we got was that all the KiCad storage files are all plain text, which is great. And so we've been having lots of fun writing Python scripts and stuff that generate circuits, and we've even been in touch with GitHub a little bit about what they might be able to add to versioning given these sorts of hardware files. So maybe looking at visual diffs of circuits and these sorts of things are very fun to think about and easy to work with when you are able to build on an open source tool like KiCad.
Are either of you working with KiCad yourself?
I do.
How do you like it?
It has its rough edges, but I prefer to work with it. I mean, obviously, as a programmer, I find myself saying, don't worry about the rough edges, I'll just fix them. But of course, I never have time for that. I haven't done anything really crazy with it. Mostly just simple two-layer designs for little shields and that sort of thing. Currently, I'm working on a wireless IMU shield for Maple Mini, and I'm doing it all in KiCad. The one big pitfall that really wasted a lot of my time was I was using a auto-converted library from Eagle to KiCad. I think someone went through and ran a script on the SparkFun library and converted it to KiCad. And when I actually made a device and I checked the Gerbers, there was artifacts in the copper layers that weren't visible anywhere inside of the IDE. And so those artifacts were actually damaging my circuit. And so now I am very distrustful of that library port. I had to go back and fix a lot of footprints. But that's been the only real non-functional thing that hurt me, and that's not even KiCad's fault.
How many of the core Arduino libraries are currently supported?
Probably 3 or 4. I don't remember off the top of my head.
There's quite a few new ones that need to be folded in to the release.
Yeah.
So in the actual drop-down menu, I think it's just 3. But if you search through the forums and the users and the wiki and other things that need to be folded in to the latest release, it's probably more like 5. I think we've got Servo is already in there, right? Wire is in there.
Wire's in there.
LCD is in there.
Yep, Liquid Crystal's in there. We have a user-contributed EEPROM compatibility library.
That's right.
Um,
Let's see, there's brushless on the way, but I don't think that's a standard Arduino library anyway. What would you like to see that's not there? To be honest, I think it would have been a stronger platform from the get-go had we sat down in week 1 and ported all the libraries. But instead, we spent most of the time spinning new hardware, and then when we did have some fresh software cycles, we devoted almost all of them to libmaple, which is the low-level library. We refactored it, and we made it a really nice kind of professional-level library that we thought anyone could build off of and focus less on the Arduino libraries. Now, I'm not saying that was the right or wrong decision. That's the decision that we made, and we're really happy with it. And I'm hoping that people get enough use out of it that they can start porting the libraries themselves, that the community can add to them. I'm not sure we have the cycles to sit down and say everything Arduino's ever done and every Arduino library's ever written, we're going to port it. We would need a lot more interns than we have for that job. Mostly the porting process, I think the main things that are incompatible besides simple int versus word, 32-bit versus 16-bit, and the ADCs are different sizes, and some of the pins moved around a little bit. The hardest thing that gets buried are these ADR.H specific things like progmem and that sort of thing. And that's all over the place in different libraries, and we don't even need that because we can write directly to the flash without it. Just a couple of macros, you can macro out progmem. So I encourage anyone listening to go on the wiki and look for missing libraries and help us out. No? Yeah.
How much Arduino code will compile without changes? Is it fairly easy to get a simple project up and going?
So Marti, just last week actually, you went through all the Arduino examples and reworked them for Maple to put in the new IDE release. What was that process like?
It was great. I mean, we have a lot of extra little convenience functions and whatnot, so many of the examples actually got shorter and simpler in my mind.
But for the most part, there was always some minor... Were there any that just stock lock, just like Blinky should work straight
Blinky
up?
works fine.
Yeah.
Yeah, obviously. Well, we do have little things like we don't have serial like the Mega. We have serial 1, 2, and 3. And so things for the stock Arduino that just use the base serial, you're going to need to put a number at the end of it.
Things like that.
Things like that.
That's actually an interesting topic that is a very big difference between us and Arduino, and also us and some other boards, including ChipKit and including Mbed, which is that we actually took the plunge and ran the USB on the microcontroller that you're using. There's one microcontroller on Maple, and it runs the USB for you for programming and for serial access, whereas other devices have an extra FTDI chip in front to give you the USB front end. Now, if I had known 2 years ago what a huge headache this would have been, I would have never done it. And at the time, we were thinking, we have a USB peripheral available to us on the microcontroller. It's sacrilege to treat it like a PIC and throw an FTDI chip in front of it. And so we're going to write a USB stack, and we're going to do everything over USB, and that'll be really nice. And in the end, it turned into a whole lot of code with a lot of bugs that took months to sort out. They could still be improved. And it was a mess, honestly. But it works nicely now, and I think in a future version, when the volumes get high enough and we can afford a second microcontroller on the board, but still keep the kind of the $40 price, we're going to put one on and follow in Arduino Uno's footsteps, where they have a second microcontroller to drive the USB. And the reason is not because of engineering difficulty. I think we've engineered out all the problems. It took a while, but we have. The reason is that if you have the USB stack running on the microcontroller that the users are running sketches on, the users don't have 100% control of the device. There's always some sort of daemon running behind them to give the USB, to run the USB, either that for programming in DFU mode or to provide the USB virtual serial interface or whatever. And so the users don't own the metal 100%. And I think that's a valuable thing to be able to offer. And with a second chip, we can do that. That's what some of the other groups do. Now, unfortunately, on some of the other boards that we've seen, that secondary chip is scratched out and with no source code, and so it's not obvious to change it. On Uno, I think they use an AVR USB, right? And that was open source, but some of the other boards aren't. Anyway, that's all I have to say about that. Sorry, that was a big part of the engineering effort in the beginning for Maple was the USB stack.
We've been trying to develop a USB stack for the PIC that's actually open source. They do this thing where their code's free as in beer, but you can't actually distribute it again.
Right.
And that's just a nightmare for developing open source. You have to give people partial code and tell them where to get other code. So
right.
we've tried to develop a stack, and it is, in fact, just an absolute nightmare. I'm really surprised you did that, and I'm going to take a look at your code and see what I can salvage.
Hopefully more than nothing. I remember when we first started, we'd been doing all our development on Linux, and we had the way it had worked in the beginning, and you can go to our documentation and read up on the bootloader, the different bootloader schemes there were. But the very first one had DFU, which is device firmware upgrade, the same sort of USB device that iPhone uses, or OpenMocha, which is actually where we borrowed it from, uses to upgrade their firmware. And that was always on in the background. And then in the foreground, we had USB Virtual COM, and they ran simultaneously. So that's your serial port. And simultaneous dual USB devices on one chip, and they call that compound USB mode. There's some other fancy names for it. And unfortunately, we did all this work. It worked great in Linux. We were really excited to release it. And it turns out that in Windows and Mac have mutually exclusive ways of dealing with compound USB devices. So you could do the appropriate protocol to make it work on Windows or the appropriate protocol to make it work on Mac, but it would never work on both. So we had to throw the whole thing out, and that was a sad day. This is back in 2009. So be careful with USB. It's just a ton of pitfalls. We ended up calling one of our friends in the same space who had been writing their own USB stack for a similar microcontroller board. I'm not going to name them, and said, how did you solve this problem? You guys run both a programming utility as well as the virtual COM at the same time. What did you do? And they said, well, we paid a consulting company and bought one, and it's closed source, and that's too bad.
That's not really a great workable solution for an open source Arduino style project. No. The Arduino is a 5-volt system, and your ARM's 3.3. Mm-hmm. And flipping through your wiki, it looks like not all the pins are 5-volt tolerant. Does that cause a lot of problems with shields?
It hasn't been. I think it's almost a misidentification of how important specific shields and specific compatibility is in general. I think most people are using the device either with their own little breadboard shields or stuff that have really popular shields that we know work out of the box, things like LCDs and motor drivers and that sort of thing, and the Wi-Fi shield works out of the box. So as long as you get a few big important shields, you should be okay. And most of the pins are 5-volt tolerant. And we do have a 5-volt line available to you as long as you're powered on something that's more than 5 volts, like USB or something. You can get 5 volts on the VN pin. One of the things that we did, speaking of shields, and I don't mean to dodge your question, but this is something that we're proud of, is Arduino very early on broke 10th-inch compatibility with their header design, and then they were stuck with it because they sold so many boards in the very early times, and people had built so many shields on top of it that they were toast. So now, in order to use an Arduino, make an Arduino shield rather, you need to cut your own PCB that has the form factor that Arduino has, as opposed to saying use a breadboard or something 10th inch, one of these perf board things. And so we just added a second row of headers that were on the 10th inch grid, and all of a sudden that problem is fixed. You can just pop in a couple of female headers into that second row, and all of a sudden you have no need to spend $30 or more on some custom form factor PCB. You can just use breadboard, which I use profusely. Every time I need to make a shield, I just pop it into a breadboard and then make a shield out of it for Maple. But Marty's pointing over here. I don't know how much leeway we have to talk about this because it's not our project, but we've made friends with the developer of Arduino, which is a great project if you don't know about it. His device is very neat. It's got an FPGA on there that lets you drive VGA monitors, and it has on board sprite RAM and some very simple functions, so you can make all sorts of video games with it and control it with an Arduino. And so he wrote us and said, hey, I bought a Maple, and I plugged it into my Arduino, and I made a couple of minor changes. Mainly, I just macroed out progmem, which is a common directive in AVR, and it works. And let me send you one. So he sent us a Arduino, and we have one here. And what a cool little device this is, and we were so pleased that it just worked with Maple stock. So that's an example of something that you might have thought would require a lot of programming. Incidentally, in the depths of the libraries, there are lots of 16 versus 32-bit things that need to get changed, but the splash screen comes up and we can draw to it and draw little pongs and that sort of thing. Very, very quickly got that going. That was a win.
How close is your peripheral pinout to the Arduino? Do you have serial and SPI and I2C at about the same place?
So we were careful to put, so Arduino has the serial lines right at pin 0 and 1 on the top right header, and so we were careful to get that right, because that's the most common lines that are built on top of on Arduino, and they wire up to the FTDI and the USB. So we have, those pins are the same. We have PWM scattered everywhere, way more PWMs than Arduino has, and I think we might be missing overlap. Arduino's checking the compatibility page right now, and a couple of pins. We moved our low noise analog plane is where Arduino put their 5 analog pins. So we have, I think, 12 or 13 Marti analogs broken out on this design. But we put 6 of them on that bottom right header like Arduino had, so that would match up. I think one glaring thing that I can see is pin 14, which is the far left. On Arduino, you can set the analog voltage, so you can rescale things in analog, which is nice. But on this particular STM32 device, that's not available. You're always scaled off VCC, which is 3 volts, or whatever you set VCC to. And so we don't have that. So that pin is just a PWM.
Do you keep a list of shields
Oh, yes.
and
Oh, yeah.
things that don't work
Yes.
or do work?
Our documentation has tables. Marty has been very careful of making sure that every pin in the different version is described in compatibility compared with Arduino.
Sure.
What functions go on each pin.
Yeah, I mean, I take our documentation very, very seriously, and since we do make claims about compatibility, I try to be extremely precise about everything, so that anybody who's thinking about our board and maybe it'll work, maybe it won't, can just look at our website, and we have for every single Arduino function, if there's the slightest incompatibility, there's a whole section on what any of the differences are, what the workarounds are, how you can adapt Arduino code. Yeah, we handle that very seriously.
About half of our customers are commercial users who don't necessarily play nice with the rest of the community, and they don't release their source code, they don't necessarily say what they're doing. And so, in a way, we're trying to straddle, so Arduino's approach was always ease of use above all else, and one click to program, and it's okay to lie in the documentation if it's for simplicity's sake, right? No pointers in Arduino language where you obviously could use pointers, or there's no return codes in functions where there are return codes, or just blatant white lies or just regular lies in the documentation that were intentional for the sake of users not being confused and ease of use. We have enough commercial users at this point that we can't afford to do that, right? We need to tell the truth, and if functions have some particular return code or of a certain type, we need to say what it is. And so our documentation, I don't mean to scare people away. I think it's certainly very readable, but it has all the information there that a commercial user is going to find essential, whereas on Arduino they don't have that constraint, I don't think.
It does seem like a trade-off if you're either hitting beginners with the Arduino IDE or going towards a more maybe commercial audience who's used to working on processors and is able to get started on one right away.
I mean, I don't think that it's necessarily a trade-off. I mean, I try to draw a lot of inspiration from the Python programming language in the sense that simple doesn't have to mean simple-minded. We can give people all the tools that they need and still make it easy. And sure, that's a lot harder to do, but I do believe it's possible, and I think we're well on our way.
You'd be surprised in how many guys in commercial settings either use Arduino or Arduino-like stuff or use our stuff and really appreciate not having to put up with, quite frankly, all the bullshit about some of the commercial vendor tools. I mean, some of us have experience in industry, including me and Jess certainly, and we've sat down and spent a weekend to try and get Blinky going on some stupid platform and install 2 gigabytes of software. And it only runs on Windows. It takes, they have 50,000 lines of some library that they expect you to build everything on top of. The toolchain is completely undeconstructible, right? And your choice is either, use the tool as we intended you to use it or don't use it at all. And by the way, attend this training camp to figure out how to bring it up and running. I don't think even pros, they can deal with that, sure, but they don't want to. Nobody wants to deal with that. No matter how good you are, and you could code this thing in Thumb2 assembly, and you've been working on ARM processors for 30 years, I think you can appreciate plugging into USB, going to the quick start page, and in 5 minutes having Blinky running. And if you don't want to use the IDE, that's fine. We have a great make build setup where you can just go to the command line rather, and see the entire tool chain from linker scripts all the way up to libmaple libraries, all the way up to what we call the Wireish library. That's the Arduino compatibility layer. All there in the GitHub directory, and you can pull it apart, and you can change it, and you can send us pull requests. And it's just so transparent and easy to get going that, as Marty said, right, you can be simple without being simple-minded. And Python is used by professionals all over the place, and it's beloved by first-year programming students. And I don't think there's any sort of real rift there.
Maple is using a forked Arduino IDE.
That's right.
And Microchip, with their chip kit, sort of went the other way, and they hacked the original Arduino IDE to be multi-platform. So it's possible now to add a new platform like Maple. Is that something you'd like to do?
Yeah, if everything moves the way that they want it to, they're trying to get their changes merged in upstream. Now, both of us, to be fair, forked the IDE, and both of us made very similar changes to the IDE in order to support the additional platform. Now, the difference is we ripped out all the AVR stuff just because it was bloat, and for us, because we were just supporting Maple stuff. And at the time, we didn't have a lot of programmer cycles to spare to support testing both AVR and ARM toolchains, so we just ripped it out for simplicity. On the other hand, the ChipKit guys left it in, and I think if you actually go through the code, you'd be surprised at well, I'm not going to say anything about the similarity of the two code bases, but we both forked. He left the AVR stuff in, we took it out, and then he went the extra mile, which I think is really important, of working with the Arduino people to try and get it folded into mainline. And I think that he was able to get that recognition from them because he was willing to make an important design decision that we were unwilling to make. And that was to set 100% Arduino compatibility as a design goal of the project. Now, in my humble opinion, I don't think that's ever going to be an achievable goal, but maybe in practice you could get 90% or 80% or some high number of Arduino code sketches to just run 100% without modification. And that's his goal from day one. And that was enough to really capture Arduino's attention. That has never been our goal. Our goal was to make the transition from Arduino to 32-bit as easy as possible, and then embrace the 32-bit platform as much as we can. And that's actually why the Maple Native board exists and why it's called the Maple Native. one of the questions we got very early on with Maple was, why the Arduino form factor? Are you attached at the hip to Arduino? Why not do your own thing? The STM32 is a different chip. It has different features. You shouldn't be following Arduino, which was designed for AVR. And we said, you're absolutely right. And so we're going to make the Maple native, which is the native form factor that we like for this chip, where analog pins are laid out in a way that's consistent with where they're located on the silicon, or that DACs and ADCs are put in an area that's consistent with how they should be grouped together functionally. And we just kind of forget that Arduino even exists.
In hardware, not in software.
Yeah, in hardware only.
All the software's the same. Just putting that out there.
Yeah, thank you. And try and move on. I think Arduino has done a wonderful service to the entire community in making microcontrollers accessible to all sorts of people, and to making microcontrollers more usable by people who could have used them otherwise. I mean, I was certainly using Arduinos even well after I was writing assembly for 8051s in class and that sort of thing. And they were great. But that being said, there's no reason why we as a community should try and say that we're going to stay with 16-bit forever, or we're going to stay with AVR forever, just because that's the dominant platform today. We should always try and build some forward momentum. And right now in the space, forward momentum, I think, at least in LeafLabs' opinion, points at 32-bit platforms. They point at FPGAs. And we hope that together we can kind of move in those directions.
Maple Mini is your new platform. Would you like to plug that?
Oh, absolutely. So Maple Mini's been excruciatingly popular since we launched it last week. We did a small promotion where the first 100 boards, and the 100 number was arbitrary in that it came in a different box from the rest of the boards. 4 of the boxes got stuck in customs, and 1 of them didn't. So we put them on sale. They were $25 for the promotion, 35 regular, and they sold out real quickly, just in a couple of days. And so now they're here, and so let me credit John Williams for doing the layout on Maple Mini. He did a fantastic job. On the front, we have almost no components other than the LED, the reset button, and then the user button, just a generic button. It has almost all the same specs as Maple, minus just a few pins because it uses the smaller 48-pin STM32 as opposed to the 64-pin. Runs at 72 megahertz. It has, let's see, a couple of I2Cs. It breaks out the USB pins so you can use them for something else, or perhaps use it for CAN, which is a spec that's very popular. Let's see, a couple of SPIs, independent analog and ground planes. We get 11 and change bits out of the ADCs, which is really nice.
Maple Mini's analog performance is superb. Since we were able to do the layout ourselves, the analog noise is way lower.
It's a 4-layer design, fits in a breadboard, and more importantly than fitting in a breadboard, it fits in your standard breadboard with enough room on both sides to still place pins. I see a lot of boards that they're 10th-inch spacing and they fit in a breadboard, quote unquote, but then there's not enough space to actually put jumpers on either side of the pins, making it totally useless. So it's narrow enough to do what we needed. And this design actually came out of a really cool project, which I can only talk a little bit about. Which is an IMU device, a motion sensor for skateboards. And Maple Mini is sitting proud inside of that device right now with it was all developed in our IDE using Maple and Wirish, and that's a very big commercial project that's well funded, and they got a lot of use out of it. So they were the first customer, and we've had nothing but good reviews from them, and hopefully you'll see that product in stores soon.
And what's coming from LeafLabs in the future?
Well, so our big so we have kind of 3 businesses in one here. We have the hobby line products, which is Maple line, and our big push there is this summer a device called Oak, which anyone who's familiar with us is probably snickering to themselves, being like, yeah, been waiting for that for just a few months now, right? Which was the original reason we even started the company, was to combine the Arduino concept, the sketch programming concept, which I'm just in love with, to the FPGA. And what a job that is. You're just fighting an uphill battle against proprietary software, against new architectures, against difficult, hardware designs to get working. But I think we're finally there. We have a Rev 1 of the hardware design that's really, really nice. It's a 8-layer board, and it has 256 megs of SD RAM. It's got the Maple class processor. It's a ZE chip, actually, the same as on the Maple native. And it has a Spartan 3 FPGA. And what we're working on now is making it as easy as possible for your sketches or your programs on the Maple side talk to the FPGA as possible. And we're taking a lot of inspiration from Gameduino, who's kind of made the less general purpose of the same concept. So he's pre-flashed the FPGA with a graphics controller, and then you talk to the graphics controller over the microcontroller, and you do that for great justice, right? So we're doing something just a little more general where you can program the FPGA as well. And in the beginning, it is going to be a lot of fixed cores where you just load up a core on the FPGA. So you want 100 PWMs, you can load up our 100 PWM core and get them. Or you want a VGA driver, or you want to do some audio DSP, you can load up these sorts of cores onto the FPGAs and use them. One of the things we're really proud of is the interface between the FPGA and the microprocessor, which we're stealing the external memory bus on the microcontroller and using that as the interface between the FPGA. So this is a 16-bit kind of SRAM driver, and that'll give us some really nice bandwidth between the two. So we've seen some projects in the past where you communicate between the FPGA over UART or SPI, but we're communicating over a big 16-bit parallel bus that's going to run at probably 25 megahertz or something like that. You'll get a lot of data bandwidth out of it. So that's what's happening in Hobbyland. We're very, very excited about Oak, and I know a lot of people who have been tracking that project are going to be glad to hear that the hardware will be available only momentarily. It exists, I promise. In consulting land, so this is something we probably shouldn't talk about too much, but I want to mention one thing that I like about our consulting work. So this is how we kind of pay the bills. We don't make a zillion dollars making hobby hardware, but we do really love doing it. And our consulting work, we're able to do two things. One is dog food our own products. We usually make sure that we can use our own boards in any of the projects, which is surprisingly an easy term to get for most of our clients. And so we get to use Maple, we get to use Maple Mini, we get to make shields, we get to write libraries, and this is a great way for us to test all the stuff when usually we don't have time to. We're too busy developing it, not enough time testing. So that's a great thing we get out of consulting. Plus, we usually negotiate ways to keep the IP for some of the libraries. I'll give you an example. Right now I'm working on a device which is going to exploit the very, very low power modes of the STM32. It'll drop down to 4 microamp sleep mode. And so we've negotiated that we're going to be able to keep this library and put it into libmaple, so you'll be able to have, enter sleep mode as a function and drop your product down to 4 microamps and make little things that stay on for months and months at a time, which we're really excited about. And then in complete La La Land, we're working on an industrial product called Willow, which is going to be an NVIDIA Tegra fast dual-core processor running Ubuntu Linux next door to a beefy FPGA. At this point, it's a Spartan 6, all on a nice, low-power embedded platform. The customers here, unfortunately, are leaving the hobby realm. I think the first customer is a fusion lab. But the whole thing was designed for robotics, and so we hope to see some nice research robotics taking advantage of that platform when it comes out next March 2012. Thanks for talking to us.
Okay, thanks, guys.
Bye-bye.
Bye-bye.